I'm only the messenger, and let me bring you the message here about what we have done in MIX. So I will try to summarize a path of 11 years of work of many people involved in a couple of minutes. And we have actually now two ways to do it. Let's do it first in a more modern way, the way you would do it using new media. We have prepared a small video that I wanted to show you, and afterwards you get the more traditional, probably more boring way of presentation.
MIX, or Mobile Information and Communication Systems, is a Swiss-wide NCCR research platform bringing together universities and technical institutions to better understand wireless communication networks. MIX research has made major advancements in environmental monitoring, public health and communications.
We want to understand the connection between climate change, changes to permafrost and rockfall from high alpine rock walls. To really understand this better, we need sensors and networks that are able to deliver high-quality, dense data from very difficult environmental conditions.
The urban air pollution obviously is a problem that is affecting the quality of life of millions of people on the world. Now consider if you can put large numbers of sensors on vehicles that are moving around in the city and producing a very precise real-time map of what's going on.
The university is developing augmented reality technologies, and one of our goals is to link the digital world with traditional media.
Over a 10-year period, researchers at top Swiss institutions have made major breakthroughs in the field of wireless communications.
The NCCR MIX evolved from some fundamental questions about the capacity of peer-to-peer mobile systems and then evolved to more application-oriented projects that would apply these fundamental understandings to practical problems.
Researchers work together to face difficult challenges in expanding the possibilities of wireless networks. Before, communication systems depended on relay stations to transmit information. But MIX specialists elaborated robust theoretical systems that allow information to be passed between nodes, eliminating the need for relay stations. In theory, ad hoc networks are more robust because they do not depend on a central station.
We studied how properties as fundamental as connectivity and capacity scale as the number of nodes becomes extremely large.
To solve problems related to large wireless networks, MIX scientists found that if the network was broken down into smaller groups and then the information was passed on collectively, the signals could be reliably transmitted. Many of the current MIX wireless applications are possible thanks to these theoretical breakthroughs. These applications bring together information theorists, specialists in signal processing, geoscientists, and environmental fluid mechanics experts. Sensoscope combines wireless technology with monitoring of temperature, humidity, and other environmental factors.
The first time we tried this wireless sensor technology was here at EPFL campus, where we installed 100 weather stations like this one. And the idea was to get a real-time picture of the campus micrometeorology.
After the success of Sensoscope on the EPFL campus, the next challenge was to take the system to the mountains to monitor the environment.
We've installed 26 Sensoscope stations in the Valferrier watershed in the Swiss Alps. This is in the context of the MIX program in collaboration with colleagues from computer science and communication systems. We are having now, for the first time, unprecedented spatial measurements of hydrologic and meteorological variables.
Environmental data is then sent back to the EPFL campus to be analysed.
These fine-grained measurements that we have in the field now allow us to improve our existing hydrologic models, which will be used ultimately to make forecasts and to understand the impacts of climate change in the Alps in real time.
At the University of Zurich and ETHZ, Scientists are using wireless nodes to better understand how climate change influences mountain morphology in the harsh alpine environment prone to rockfalls and extreme climatic conditions.
Within MIX, we installed many sensors that included temperature sensors, crack meters, and automatic cameras. These spatially distributed and very dense measurements helped us to get insight that we didn't think possible only a few years ago.
We've mounted our sensor networks on the peaks of the Swiss Alps on the Matterhorn and Jungfraujoch. They've been operating for multiple years now, churning out many millions of data points, and the first research results derived look very promising.
The MIX Spin Fund translates these applications into commercially successful ventures by giving scientists the skills to start a successful company.
From the NCACR Spin Fund, a number of companies grew on the ecosystem of very large quantities of data acquired by distributed systems. It could be environmental data, it could be images or video. So companies then make sense out of the data to create value for consumers or other companies.
OpenSense combines sensor technology with the mobility of public transportation to monitor city pollution levels.
In OpenSense, we are using sensor-scope technology to monitor the air quality in the city of Lausanne. Traditionally, this is done with very few stations, so that you can, for example, not say what's the difference from one street to the other. By putting a number of stations on buses and letting them drive around, this is if we would have a very large number of stations, and this gives us a very precise picture in real time of what is going on.
This information will allow citizens and policymakers to assess urban pollution's impact on health and the environment. Thanks to novel approaches to communication theory, CANDO reduces energy consumption in servers and other devices.
CANDO Bus is a licensing company. We license technology for serial links that reduce the energy consumption of electronic devices while making them faster. We do this by using communication theory in a way that has never been used before, and we've raised $10 million beginning of this year.
Advances in data management and signal processing also help consumers make better sense of the world of information around them through images and video. Vidinotti uses MIX technology to develop new augmented reality applications for smartphones.
The user can just point their phone to an article, and the article will be recognized and augmented, for example, with videos.
Other MIX Spin Fund startups, like Croppola, specialize in automatic online photo cropping.
Croppola is an online application that automatically and intelligently crops photographs.
And Pix4D provides fully automated software solutions to combine aerial images to produce meaningful 2D and 3D representations. Thanks to the MIX platform, researchers will be able to solve problems relating to big data management in the near future.
Among large quantities of data of importance to humanity is certainly environmental data relevant to global pollution, global warming, and questions of environmental safety. This data not only needs to be collected, it needs to be put at the disposal of the general public and the scientists in order to have transparency about these key issues.
10 years of MIX research and collaboration has resulted in scientific breakthroughs and innovative commercial applications. Its research has truly opened new frontiers in communication systems, and its results will continue to improve public health, increase our understanding of environmental changes, and nourish communication applications for years to come.
More mediatic way, right? So, and I hope that in particular also the Swiss National Science Foundation will benefit from this a lot in publicizing our efforts in the periods to come, in particular when it comes also to basically talk to the politics and convince them that this was a very good investment. Okay, now unfortunately I will do now a presentation the traditional way, which will be definitely much more boring, right? But I think it's worthwhile to give you some. Yeah, so you see information technology. Okay, to give you some background on how all of this came along, also a bit of perspective over the time of how MIX has been evolving. And for many of you who probably hear today the first time of MIX, probably also to tell what MIX is all about. So the story began in 2001 when the SNF decided to launch a new program for strategic initiatives, which have kind of a double mission. They were aiming, as the SNF is mainly funding basic research, of course, to foster research excellence in dedicated areas in universities, and at the same time combine this with technology transfer and information, and also in that way change basically the Swiss landscape in research. And there was the first wave of NCCRs. There were 14 that started in 2001 across all the fields. I mean, this life sciences, physics, and so on. And there were actually 2 also in information technology, which I think was a very important fact. And one of the 2 was the NCCR MIX on mobile information and communication systems. So what was kind of the background? I mean, why this theme of mobility has been coming along? I think it is in the air since long that basically we have created a virtual reality in the 90s with the internet, and it coexisted a bit with the physical reality. But over the years, these 2 spaces are going to be more and more entangled, and the enabler for this is clearly wireless communications. And now 10 years later, I mean, we see many of the outcomes. You have seen it in the movie, but of course also, for example, the smartphones we are carrying around are a clear indication of that. So the NCCR MIX has been tackling this space of how can we bridge basically the physical reality and the virtual reality, and how can we find new forms of communication, both from the level at the level of theoretical investigation, fundamental principles, then also in systems developments, and finally bringing this to applications. And you have seen actually many of those. So NCCR MIX is a network. It's a research center that involves a number of institutions in Switzerland. You see there is an axis, which is naturally because the main centers of research in that domain are at ETH in Zurich and EPFL, but also it was networking with a number of universities. You have seen, for example, we have worked with University of Zurich in geophysics, or University of Bern, Basel, and also Lugano has been playing an interesting role as they have been growing a computer science department during the lifetime of MIX. So all of this was a long program, and of course over a long time you can accumulate big numbers, and I think the numbers have become quite impressive at the end. So we have overall a budget that we have spent of 106 million francs, so this is big money, right? And what is very nice also from the perspective of the funding agencies, that out of the 35 or so million that have been invested, actually the center could leverage additional funding both from the participating institutions but also from other funding agencies that basically tripled every franc invested. So from the perspective of a scientific funding agency, this was really a very good investment, I would say, and that's a message to pass on also to politicians. Many people have been involved, so you have seen already some outcomes, and you have seen some of the people, but you have to figure out that it was more than 60 faculty members, 100 postdocs, and almost 300 PhDs have been completed within the framework of MIX, with quite a number still to come. We have also set up an industrial liaison program. You have seen the logos of some well-known companies in the IT space, and they have been accompanying us over the years, and we had many different types of interesting interactions. So to put all of this together, it was one of the largest coordinated research activities in this space worldwide. We know of another one in US at the West Coast, that is the Sense Center in Los Angeles, which is kind of a bit similar, has a similar duration, and I think this shows, I mean, how important this initiative was, that there are not so many places in the world where this has been done at that scale. Okay, so let me give a bit of history. So we started in 2001, and these centers, they operate in phases, and these phases, in reality, they're aligned with the lifetime of PhD students, which is about 4 years. So there was a first phase, which started in 2001 and 2005, then the second one, and the third that was a bit shorter, that started in 2009. So what was the fundamental setting in 2001? So this is kind of the story that has been told at that time. Probably you still remember there was this auctioning of UMTS licenses going on at that time, and fantastic amounts of money have been generated for the state budgets at that time. So it was a very hot topic, mobile communications. But this was, of course, focused very much on centralized telco infrastructure. So with MIX, so that was really the idea that was brought up by the founding fathers. They have been mentioned, Martin Vetterli and Thomas Gross at that time. Why should not an alternative way of use mobile communications be investigated, which is based on principles of self-organizations and low cost? And so the idea was that instead of having only kind of antennas, which people often don't like so much, that can communicate with devices, that you make the devices communicate among each other. And there were a lot of questions that were completely not understood at that time, ranging from very theoretical questions. For example, what is the capacity? How much information can you transport in such a self-organized wireless networks? How big can they become? How do you solve technical problems? How do you deal with technical problems of transmitting the information, protocols? How do you deal with security issues, quality of service, and how do you build software on top of it? And finally, also, how can you create business? And we had at that time already a vision on the applications, and the one that was put forward was sensor networks. And in the film, you have seen that this has become indeed a major focus of the center, but there were many other ideas around. Some have become more successful, some have been fading out. So, for example, operatorless handies, I even don't know exactly what that should be. So, of course, it was not understood the field, and that was the reason why this initiative was started. And then the research started to organize, and I mentioned here just a few areas that have been tackled. You have seen yesterday, hopefully, many of these research outcomes already in actually a very nice program that gave a summary of some of the achievements. But some of the main topics were on self-organizing networks and theoretical foundations of those. So, for example, how can they become connected? Then how to engineer wireless networks. So there has been work going on, for example, how to build wireless ad hoc networks where information is transmitted over multiple hubs. Then a lot of work went into wireless security, which was a completely new field because in 2000 this was just not a problem yet. So the question was already to figure out what are the problems and then to find, of course, also protection against potential attacks. Then data management, nowadays it's well acknowledged that data that is coming out of sensors is overwhelmingly the most important source of data in the future. So how can we deal with this data? And many questions related to signal processing. So because all of the data that is acquired to sensor needs to be properly interpreted and processed. So these were key areas of research that were tackled through the lifetime of MIX. And then the second phase started. So we started with this research, but then at some point, of course, there was a desire also to go to applications. And then you have seen in the movie, this was really then something where we were more outgoing, more visible also to the kind of general public, because we are going into the physical space. And we made a very conscious decision at that time to choose environmental monitoring for various reasons. First of all, it has, of course, lots of interesting scientific questions. We had also partners at the universities in other fields, like in environmental sciences we could work on with. And of course at that time, and to a certain extent still, I mean, it was not a field that was very strongly driven by business. So it was a good investment because in other fields there was so strong business interest that we probably would not catch up with industry at some point because investments there would be large. And we started to look into different areas, so as you've seen, we're into alpine regions. That was, of course, quite obvious, but then later on also developing countries, but also inside buildings, for example, and also questions, for example, pollution in urban areas. And this led then to projects that culminated kind of in the idea of having something like data-driven environmental science. So from the classical approach that was taken in that field, where you have typically remote sensing, like satellites, or you have very few fixed stations, we would have kind of networks in situ sensing that transmit also in real time the information, which was also a new thing. And the realization came very quickly that this goes much farther, because it's not only producing this data, it's also using this data, bringing it to use. And in that space, we kind of also very early certain trends in terms, for example, that are tackled nowadays under the acronyms like big data. And we also looked very early in questions like crowdsourcing of data gathering tasks and similar. Also in that phase, we realized that we cannot only investigate isolated research topics. I mean, that is very important to have fundamental understanding of specific questions, but the next step is then bring things together. So how can we build now systems that integrate all these ideas? That's of course not a one-to-one process, but I think we succeeded in many places to build really systems that kind of capture the whole life cycle of getting information from environmental sensing, transmitting it over networks, processing then the data, and finally make decisions also based on the data that is gathered. And that influences again, of course, what you will measure in the future. So in that phase, we developed lots of systems and applications, but then the question comes up, what are we doing that? And that was kind of the third phase, focusing increasingly on technology transfer. And one of the programs that we set up a bit earlier actually already, but focusing mainly on this third phase, was the Mixed Spin Fund program. And in the afternoon, we will have a much more detailed presentation on that, but I can tell you here already it was a very successful program, but we did also other things. We brought companies on campus, some companies came, others left in the meantime. We had collaboration projects with industry, and we set up new application-oriented projects. Now let me summarize some of the key achievements that we have achieved in each of these fields. So in basic research, we found answers. So we have over the last year put a lot of effort into figuring out what were kind of some of the key questions that we could answer over the lifetime of MIX. So for example, with respect to wireless networking, a big question is actually how much information we could transmit. At that time, there were some famous results that said this is the limits. In the meantime, we know that we could push these limits a bit further. In wireless ad hoc networking, a big question was always energy efficiency. So what is the answer? Actually, the answer is that to build energy efficient systems, you have really looked very carefully at all the various different components and to engineer this nicely together. In security, we have many different types of attacks, very strange attacks actually, that you could imagine in wireless networks. So let me just give you one example that is actually currently also going to commercialization. For example, you have now the wireless keys for cars, and of course you could intercept the signals, and that's a very easy way to steal cars. And it's become, as far as I understand, industry already in certain circles, right? So in data management, it turns out that it's not enough just to shuffle around data as bits, but it's very important for efficient solutions to understand actually what the data is used for, what is the meaning of the data, what's the semantics of the data. And also in signal processing, we saw a very interesting evolution in the sense that many of the traditional assumptions that have been made in kind of the classical centralized processing, as soon as we built these wireless distributed networks, do not hold. At the same time, we saw that many new opportunities of how the processing could be done emerged. So all of this, of course, I mean, cannot be grasped in a short presentation of how much invention went on, of how much creation has been happening over the years. So then you take the simple approach, you start to count, and this is, of course, also something that is very closely looked at usually by administrations, and I think the numbers are expressive. We have more than 1,700 papers that have been peer-reviewed conferences. Now, 1,700 is a big number because each paper is a lot of work, right? Each of these results is one paper, so there was enormous amount of output. We had many past papers awards, and for those of you who know what an H-index is, the center has broken the mark of an H-index of 100 within 11 years, which might become a very interesting metrics for administrators in the future. But there are also more qualitative kind of signs of the excellence of the research. So you see here, and I cannot go through all the names, but you see here many of the participants of the mix have received very prestigious awards over the lifetime. And Philip mentioned it already, many of the young colleagues have also got, and not only the young, as you see, also of the older ones actually, have got these prestigious ERC, European Research Council grants, which are considered like as research distinctions nowadays in Europe. Okay, so for applications, the movie has already told you almost all of the story. Let me recap in how many strange places, many of those, by the way, by Mark, we have reached out. So we started at a simple place, the EPFL campus, and if you walk around, you see the station still. So this is running now since 5 or 6 years and gathering data on campus on typical meteorological data. But then the campus was boring, so we saw installations in Planmort, a glacier, Genepi, it's a rock glacier, on the Jungfraujoch and on the Matterhorn, so we have covered the most famous mountains in Switzerland, in Davos, and then it was, after all these cold deployments, there was the desire for more moderate temperatures, so we had deployments also in Africa, in Burkina Faso, and then finally also now with respect to air pollution on the public transportation infrastructure of Lausanne, in buses in Lausanne, and in Zurich it is on the tram network, and gathering quite a novel type of data as compared to what we have now. Now all these kind of developments that we have done in MIX had also impact outside of Switzerland. So, and one of the big impacts we had was in terms of getting involved in European projects with partners both from research and industry. More often than not, what happened is that some of the investments that MIX could make due to the generous support of the SNF, where we could choose our research topics relatively freely, enabled us to be ahead of the general research trends, and in that way we became extremely interesting partners in this type of projects. And I know of a couple of cases where basically people took literally results from a mixed project and said, we would like to build now a project around that at the European level. And just to give you a number, over the years we have obtained in these programs a total of around 30 million francs, which is also significant. In industry we have collaborations. I just highlight 3 examples. So we had a very nice collaboration in the context of this environmental monitoring with Microsoft Research, who had a big program on e-science. We built in that program what is called the Swiss Experiment, a platform for environmental scientists to share data and to gather sensor data. We had the Nokia Research Center on campus, so unfortunately you know that Nokia is slightly in trouble financially at the moment, so they are currently reducing their operations, but I think it was a very successful collaboration. It's also that one that's going on, and I hope really very strongly that Nokia will find the turn and go on the upslope back again. So that's industry, it's much more volatile than research, of course. And then we will see this afternoon also one example of a very nice collaboration we had with Siemens, where some technology from X was really transferred into what is now a product for fire detection. And I very well remember the first talk I heard about it, where you saw very nicely the difference between theory and practice. Yeah? Because, for example, something a researcher never would think is in a sensing environment that actually you only sense once. A fire sensor senses once in its life, if at all. And that is when the fire is, and then it is destroyed. But this one sensing needs to be perfect, otherwise you are in big trouble. And then we had a lot of success with the Spin Fund program creating startups. So we had planned this program 2008 or so, and Max Monti, who is sitting here, happy to see him, was the guy who was really pushing it at that time, and we were scratching our heads and saying, okay, is it a good idea? Will it be successful? I mean, if we do it and nothing happens, it's a bit embarrassing and so on. So we would be very happy to have probably 3 or 4 good startups coming out at the end. So this thing was kind of really taking off. It had what I would call a viral effect. Once people saw in the center that it is possible to create startups, suddenly others got interested and all kinds of ideas came up. And at the end we had, actually we had 16 of these PIN funds that were supported out of 25 publications. We have now 10 companies incorporated. Number 11, Sabine, is already sitting in the queue. You have heard some numbers, so some of them have now risen serious venture capital in the range of $10 million US and similar. So it was hugely successful, and actually it's quite clear that even the CTI, so that is the Swiss funding agency for technology transfer, is kind of a bit jealous of this program that SNF has launched, and now they think about how they could do it themselves. So I think this was a very big success. Now, apart from this kind of more research and transfer-oriented output, I mean, we should not forget that, of course, the most important output of such a center is people. And we have 154 PhD students, if I recall right, that have so far finished, and there will be many more coming after. And many of them have received, in the meantime, very prestigious faculty position. Many of them are now active in the companies that we have been working with in the ILP program. So I think this is a very profound impact, and the network that we have created by that way is very active, and many of the existing research collaboration that EPFL has in this space are based on this network. So one of the major concerns that SNF has, and actually also EPFL has, is that like in many countries in the West, we have a problem to attracting young people to this field of engineering, to the field of information technology, and in particular also to attract young girls to that field. And MIX made serious efforts to improve that situation, and the philosophy was really that you have to start at the roots, at the education at the very early level. And one of the outcomes of this was the Internet course for girls that was set up, I think 2003 or 4, and regularly offered to young schoolgirls courses giving an introduction to how to design a web page, how to publish on the Internet. And it was hugely successful. We're counting now the 2,000 participants. I mean, if you think about, these are all people coming from the region, you multiply it by the number of parents and relatives, so you have an outreach of 5,000, 6,000, 7,000 people that have been coming by to EPFL or hearing about the program or having some feedback. I think that is really significant. And in the meantime, also some surrounding cantons have started to take over this program. We have also worked together with EPFL on other initiatives like the Science Bus, where we go to schools and present science as an exciting endeavor. The Robotics Center that also attracts interest to engineering and programming. And we had, of course, also a lot of support at the more senior levels. But I think this is still something we have to strongly work on over the years, as the numbers show. All of this work has created, of course, also some echo in the press, and probably you have seen some of these things. It is not always clear that if you read an article about an achievement that has been done in the center, that this was done by MIX, because no one is, at the end of the day, in the general public interested in that fact. The people want to see results, they want to have exciting news and stories. And so this is also one of the basically traces that we have been leaving over time. Okay, so there is also, I mean, one point that is particularly at the heart of the SNF, and that is what is finally the impact of such a major investment into research. Of course, we produce all these outputs, but I think the impact goes deeper. It is changing of how organizations work, and I think probably it's also very important to realize it is changing of how the people in these organizations are working. So it is clear we have at the participating institutions, so in the two main partners, we have lots of visible things at the level of organization. So we see that many of the faculty at EPFL have been hired in the context of MIX or have been associated with MIX. We got a new building. Of course, part of this was also that the faculty had really was on the uprise due to this center. At ETH, a very important institute for pervasive computing has been founded. This is now attracting one of the most popular, or the most popular course in graduate education in mobile communication. So these are quite visible things. Oops. So But what's also important is that the links have been created between these two institutions. And we know that it's not always easy to work together, fighting for the same pot of money as ETH and EPFL are doing. But nevertheless, we also see the value in cooperation, and MIX has really been one of the major axes along which these two institutions have cooperated and will continue to cooperate as a result of the MIX. Because the difficult thing is always to initiate these interactions. Once you have established the links, they continue typically to exist because they're normally also beneficial to both sides. But there have other links been created. So we have seen environmental science. So 10 years ago, I mean, probably we would not even know the names of our colleagues in environmental science. Now they're regular partners of us in setting up new exciting projects, and also we're kind of very complementary. I mean, they have the domain knowledge to solve some of the most important problems of our world, and we have the technology to help in these solutions. We have also established big links with industry. So I have talked a lot about this, and I think also this has led to a change in the mindset of people. I remember well, 10 years ago, there was a huge discussion going on in Switzerland about the inability to turn excellence in research in economic value. So, and people were looking to Silicon Valley and were saying, why are they able to create one company after the other? And in Switzerland, not much is moving. We are also very good in science, but we don't really turn this into value. Now, I think a lot has changed, and I think we contributed also a significant step to this. I think the people now have really gained belief it is possible also here, despite it's maybe still a bit more difficult in some ways. But I think there are also certain probably advantages in this environment here, and now the things are moving on much differently, and I think these discussions have really gone away. So it is really about networking at all levels between disciplines, between institutions, and also with academia. And this is, I think, something that will last really in the heads of the people ultimately. So if I look back now, I was asked at some point to assess whether we were foreseeing the future right, which I think is kind of a bit a difficult task. So, and if you look back, actually there happened many things that we did not foresee. So no one was talking 10 years ago about cloud computing, and that energy consumption was becoming one of the major obstacles. So right, energy consumption on mobile devices, that was clear at that time. But energy consumption in the back end, no one was really thinking about that. Then something happened that was completely kind of a phase transition in how we use the internet, social networks. We were talking about peer-to-peer networks, but this was kind of a rather asocial network, right? And now it turned into social networks, and this was kind of revolutionizing how people were using the internet. Of course, we were talking about mobile devices, but we couldn't foresee that they will turn basically into universal devices that do everything, like smartphones and iPads and all these kind of machines. And of course, we could not foresee in 2001 the crash of the internet bubble, which happened basically 1 year later. And fortunately, we were fast enough to get the center in, because I would doubt that 1 year later it would have a lot of success. But I think we see also a resurrection. I mean, it's the typical thing. There are a huge, high expectation, then you have a huge disappointment, and then you go up to a level of where you can go make real advance. We had also many things that we imagined, like piconodes. So no one is using that word anymore today. We call it just simply sensor networks. Or people were thinking about, myself including, peer-to-peer search engines. Which was a miserable failure because our answer time is just too long, right? We cannot compete with Google. But I think it is becoming a more and more urgent problem in terms of all the privacy discussions. So we will probably see even a resurrection of that area. But we were ahead in many ways also. We very clearly recognized at that time the importance of self-organizing network. And this was a team that was carrying on across all fields, across all technologies, and it will so in the future. And I think it was a very wise decision to put a lot of emphasis on that. And I have to in particular credit Martin, who arrived in the meantime, for having insisted on this theme all the time. Also the engineering of cyber-physical systems, the involvement of communities, the creation of big data, and also in the last few years, the increasing importance of privacy. These were all kind of topics that we have been taking up very early. So, and you see that there are now big programs coming up. One that is already running for a while, Nanoterra, but now there is Future ICT, Guardian Angels, and so on. And if you carefully read what they are doing, I can see many things that we have been already investigating for a long time. So there's a lot of things reflected in this, and it shows also that I think it was really a very far-sighted decision to start NCCR Mix at that time. Okay, so before finishing, I would also acknowledge a few people that have been carrying the center for many years. So, yeah, okay, you have already said thanks to all the old academics, right, Martin? You missed this point. But I think it's very important to acknowledge that the center would not work with the contribution, without this contribution of these people who really do the hard work that is in the back. So there is Jacques Beauvais. He was the scientific coordinator from the beginning. So he was responsible for everything. I mean, all the questions ended up with him. So then Heidi. So whenever I had a problem, I just called Heidi. Thank you very much. By the way, she was taking care of the finances, the most important person probably, right? Then Dennis Rocha. You see, he is making things work. Thank you. Then Max Monti. So he was for 2 to 3 years. He was starting the Spin Fund. He was technology transfer officer. So he's a very creative person, actually. And finally, Roland Besty. He has been taking over from Max the technology and has brought it to flourishing with a lot of hard work in the background, networking with all kinds of organization in that space, which is sufficiently complex in the Swiss landscape. Okay, so that's where I would like to end and not longer withhold you from the much more interesting presentations on exciting stuff that has been going on within Mix, but then also some outside views that you will see over the day, looking at this from different perspectives. And in the afternoon, we will have also the startup companies present. And finally, you have to wait really to the last session, because there the future president of the SNF will give his view on the whole center. So I think this is something that we would all like to know what he has to say. Thank you very much.